Remember the ask not what your country can do for you, but what you can do for your country rule? These chiastic rules for limits. The limit of a sum is the sum of the limits. Same thing is true for derivatives. Let's go to the board. Here's the rule for derivatives. The derivative of f plus g is the derivative of f plus the derivative of g. In short, the derivative of the sum is the sum of the derivatives. Why does this make sense? Well, think back to what the derivative is measuring. The derivative is measuring how changing the input affects the output. In this case, I want to know how changing x affects the sum of f of x and g of x. Well, the sum is affected by the sum of the effects. The sum of the derivative of f and the derivative of g. Let's see this in a specific case. Here's a specific case. The function f of x equals x cubed plus x squared. Let's differentiate this. I want to calculate d dx of x cubed plus x squared. Now this is a derivative of a sum, which is the sum of derivatives. Now we have to figure out what's the derivative of x cubed and what's the derivative of x squared. That's the power law. The derivative of x cubed is 3x squared, and the derivative of x squared is 2x. And now there's no more d dx's. We've calculated the derivative. The derivative of x cubed plus x squared is 3x squared plus 2x. Once we know this, we can figure out where the derivative is positive and where it's negative. So the derivative was 3x squared plus 2x, and I want to know where that's positive and negative. Which values of x make that bigger than 0? Which values of x make that less than 0? One approach to thinking about this is to factor 3x squared plus 2x. I can write that as x times 3x plus 2. And once I've factored it like this, I can figure out the SIGN of this by figuring out the SIGN of these two terms separately. To visualize this, I'm going to draw a couple number lines. So x, here's a number line. X is positive when x is bigger than 0, and negative when x is less than 0. That's not too complicated. What about 3x plus 2? Well, 3x plus 2, if I draw a number line for that, the exciting point is minus 2/3. When x is less than minus 2/3, 3x plus 2 is negative. And when x is bigger than minus 2/3, then 3x plus 2 is positive. Now, I don't really care about x and 3x plus 2 separately. I want to put them together, right? I want to know when their product is positive or negative. So I'll write down the product, x times 3x plus 2, make a new number line here. I'll record both of these points, minus 2/3 and 0, and then I can think about what happens. When x is less than minus 2/3, then x is negative and 3x plus 2 is negative, so the product is a negative times a negative, which is positive. When x is between minus 2/3 and 0, then x is negative, but 3x plus 2 is positive, and a negative times a positive number is negative. And finally, when x is bigger than 0, well, then x is positive, and also 3x plus 2 is positive, so the product is positive. So here on this number line, I've recorded the information about when 3x squared plus 2x is positive or negative. Now we can use this information to say something about the graph. Here's the graph of the function x cubed plus x squared. It goes up, down, and up, and that's exactly what you'd expect from the derivative. Right, we calculated before that if you're standing to the left of minus 2/3, then the derivative was positive, and indeed the function's going up. Now once you get to minus 2/3, the derivative is 0, but then over here between minus 2/3 and 0, the derivative is negative, and indeed the graph is moving down until you get to 0 when the derivative of this function is positive again and the graph is going up. Look, the SIGN of the derivative, positive, negative, positive, is reflected in the direction that this graph is moving. Increasing, decreasing, increasing. Incredible. By being able to differentiate x squared plus x cubed, we're able to gain real insight into the graph of the function. We're not just plotting a whole bunch of points and hoping that we can fill it in with a straight line. By looking at the derivative, we know that the function is increasing and decreasing. We're able to say something for sure.